Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul binti Surani, and today I will present about my research study entitled Fabrication and Hydrophilic Modification of 15% polysulfone membrane at low microcrystalline cellulose concentration. So this is my overview of poster. As you can see, this is my introduction, my problem statement, objective, scopes, result and discussion, methodology, and last but not least is conclusion and recommendation. So as for introduction, carbon dioxide or CO2 gas is considered as the most harmful gas and lead to many environmental issues. Its atmospheric concentration has been recorded to rise relentlessly through years. Consequently, many tremendous impacts happen, such as global warming and climate change. As such, many researchers and industry practitioners have been applied membrane technology to capture this CO2 gas. However, the technology can cause large resistance in liquid and gas mass transfer, hence, it's reducing the membrane performance. This research came out with better alternative whereby polysulfone or PSF was chosen as best polymer material and N-methyl pyrrolidine NMP as an organic solvent. Since PSF shows strong bond properties that has led to hydrophobic behavior, the microcrystalline cellulose MCC is introduced into fabrication process. MCC is a hydrophilic filler which possesses the abundance of OH or hydroxide bond. Next is problem statement. The bonds inside the PSF chemical structures helps the PSF to form a very stiff and very strong polymer. The strong bond between them has led them to very hydrophobic in nature. MCC is one of hydrophilic fillers which can be a supportive materials to improve the hydrophilicity for the membrane. This is because MCC possesses abundance of OH, which is hydroxyl group that consists of very small particle and can provide a very large absorption area. Although true MCC modification towards PSF membrane seems susceptible to cater this problem, however, this membrane seems to have a challenge to provide a smooth and effective way to capture carbon dioxide gas due to the incapability properties of membrane itself. Next, from the problem statement that I previously stated, the objective of this study is, number 1, to fabricate the feed-modified hydrophilic membrane with different microcrystalline cellulose content. Number 2, to characterize the modified cellulose membrane structures and properties. Number 3, to evaluate the permeability performance of modified polysulfone membrane. And lastly, to compare the adsorptive fouling behavior of modified polysulfone membrane with commercialized membrane. Next, to ensure the accuracy in the experiment was limited to number 1, PSF as the base type of membrane materials. Number 2, the concentration of PSF and MCC at certain range of weight with the total basis 100 gram. For analytical testing, the membrane was tested using FTIR, WCE, and PWF test to characterize the membrane properties and its permeability performance. Lastly, number 4, the fabricated membrane was verified under BSA rejection flash rate for protein fouling analysis. Next, we move to methodology. The experiment was firstly began with the membrane fabrication process. Firstly, the NMP was mixed with MCC granules for 24 hours before they were added with PSF until it fully dissolved. The solution was then been sanitated for 30 minutes. The solution was then casted on the glass plate using a glass rod, and after the thin film membrane was formed, the membrane was then immediately immersed at coagulation water for 24 hours. Here, where the phase inversion process happened completely. The membrane will let to be dried at room temperature for another 24 hours before they are ready for characterizations and performance tests. The performance tests are including WCA, FTIR, PWF, and BSA rejection tests. Alright, next we move to the important part, which is results and discussion of the study. Firstly, for WCA contact angle, the angle reading is remain decreased. This proves that the additions of MCC develop a hydrophilic PSF membrane. Further increases of MCC amount in PSF membrane helps to improve the hydrophilicity properties by showing the least water contact angle on membrane surface. Lower contact angle signifies high water contact angle due to the hydrophilic character of MCC, which possess many free hydroxyl groups. In fact, MCC acts as a major reinforcement agent to enhance the membrane morphology and mechanical properties. This is because they hold strong microfibril aspect ratio and fibrillar structure. Each of these microfibril structure is made up by hydrogen bond that create a strong adhesion force of water. Hence, it helps to recover the membrane pores and increase the membrane performance. Next, we move to FTIR, which is the spectroscopic reading test. So here there are two different figures, figure A and figure B. Figure A is showing that the new PSF, which is no MCC added, at peak 557, at 33 and 2970 is showing that CO and CH bond existed in this membrane respectively. At 1151 and 1240, as well as 1585 is recognized as a sulfone group, which is indicated as OSO, COC, and CC aromatic bonds respectively. Furthermore, at peak 1488 is showing that C double bond C bonds, and at peak 3744 here is represent the OH bond that existed in strong intensity. This portrays that hydrogen bond is existed at abundant amount of PSF membrane. Alright, next we move to the second figure, which is figure B. This is the PSF with 0.1 gram MCC added. This is PSF with 0.5 gram MCC added. And this is the PSF with 1.0 gram MCC added. Briefly, the graph is depicted with the same outcomes in figure A, which is they're slightly different with the very weak intensity at peak 1740 here. That's showing that there are acetyl and uronic ester groups of hemicellulose that resulted from the process of oxidation of carboxylic acid for the cellulose membrane. So next we move to pure water flux PWF test results. As shown in figure here, there are water flux rate that increasing. This confirming that by increasing the MCC content lead to the membrane hydrophilicity improvement, because MCC is functioned as a good promoter to enhance the membrane porosity. The increment of MCC amount during membrane fabrication process helps to improve the hydrophilicity and water flux performance. Cellulose molecule that holds many hydroxide radicals that form strong hydrogen bond between molecules. This is because MCC is a cellulose that consists of small dimensions and have a large adsorption area. So they contain many vacant hydroxide radicals exposed. The vacant properties allowing the membrane structures to have well pore distribution, in which successfully show strong capability in moisture absorption and adsorption. With good adsorbent properties, the membrane can further accelerate the water diffusion during the phase inversion process. Next, we move to the last results, which shows by the BSA bovine serum albumin test. So, as shown in figure here, the commercialized membrane shows the BSA rejection as 10%, followed by the need-fabricated PSF membrane, which is no MCC added, as 2%, and the percentage is slowly increased after 0.1 gram MCC is added, showed that 4%. And surprisingly, after 0.5 gram MCC is added, the rejection test increased to 65% and slowly decreased after 1.0 gram MCC is added, which is the 63%. This was inferred that the MCC modified fabrication membrane have better BSA rejection percentage compared to commercialized membrane. The higher reading in modified membrane described that the membrane have low fouling potential. Specifically, the most anti-fouling properties was attained by 0.5 gram MCC, and the least anti-fouling behavior is shown by the neat fabricated membrane. The remarkable results were shot from the 0.5 gram, which is it have a maximum rejection test. In contrast, further additions of MCC content was resulted to smaller average pore diameter, in which was led to the thickened top layer, and hence it lowered the rejection efficiency, which shows by the 1 gram MCC added. So, it was inferred that the MCC modified fabrication membrane have a better BSA rejection percentage compared to commercial membrane. The higher rejection reading in modified membrane described that the membrane have low fouling potential. Specifically, the most anti-fouling property was attained by 0.5 gram MCC of fabricated membrane, in which the BSA was rejected in maximum level. The remarkable results that shows from 0.5 gram and 1.0 gram MCC of fabricated membrane is attributed to the porosity and hydrophilicity properties that significantly improve. In addition, this membrane were believed to have many lower fiber diameters, in which helps the membrane to gain better hydrophilicity behavior. In contrast, further additions content of MCC was led to the thickened top layer. Hence, the membrane have a lower rejection efficiency, as shown in 1.0 gram MCC added of fabrication membrane. Last but not least, the conclusion of the study. The study was performed by using PSF as a base polymer with NMP as an organic solvent and MCC as an additional hydrophilic fillers. The results from WCA and PWF tests proved that by increasing the MCC concentration helps to improve the membrane hydrophilicity. The flux test gave positive trends, and water angles was appeared to be lesser, in which showed that the membrane have good affinity towards water. These affinity bonds were studied by FTIR test. This test was portrayed that MCC modified membrane hold abundance of hydrogen bond, of which hydrogen bond helps to improve the membrane performance. The BSA rejection percentage depicted that MCC modified membrane have higher rejection reading, which proved that MCC modified membrane have better anti-fouling performance than commercialized membrane. Thus, this study demonstrated that the strong preliminary results of which could help in further modified cellulose membrane experiment to capture CO2 gas. So next, as for recommendation of the study, firstly, to investigate the membrane morphology more truly, the membrane should include the SAM and AFM analysis in characterization study. Second is BSA rejection test should be done with the same type of commercialized, which is the polysulfur membrane. Third, the membrane should store in dry condition before the performance test conducted. Lastly is the MCC and PSF that were added in fabrication must further study to maximize the membrane's performance. So the last is the reference. And as for the acknowledgement, I greatly acknowledge and thank you for all the supports from the Faculty of Chemical Engineering and to all the lecturers, family and friends. Thank you for the continuous support, and I'm very honored to receive it. Thank you.